In this talk, we're going to give an approach to DICOM anonymization. The first thing to understand with anonymization is that it's not a one-size-fits-all process. There's not just one perfect DICOM anonymization script out there that would serve the needs of every project or for importing image data from every source. If there was, we could just code it up, stick it in XNAT and be done, and we wouldn't have to have the rest of this exercise. The other thing that we need to re-emphasize is that DICOM anonymization is an exercise, ultimately, in risk management. This data is extremely difficult to fully anonymize or de-identify. And if your plan is to share data publicly, then no amount of DICOM anonymization will suffice. Converting DICOM data to NIfTI or BIDs is our recommended approach to public data sharing. With those caveats in mind, let's talk about how to develop an anonymization scheme that works for the projects that your XNAT supports. First, consider where to apply anonymization. As we've mentioned in the previous unit about image uploading, there are 2 points in time where DICOM anonymization can take place in a standard upload process: client-side or server-side. Client-side anonymization happens outside of XNAT before data is sent to the server, and server-side anonymization happens inside XNAT during the import process. Inside XNAT, there are 2 server-side anonymization points. The site-wide anonymization script is applied during the initial importer process as the data is being imported into the pre-archive. And then project anonymization scripts are applied during the archiving process of moving the session data from the pre-archive to the final project-specific folder in the archive. How and where you set up your scripts will depend on your import method, how many projects you plan to support, and what your IRB requirements are. Typically, your site-wide anonymization script applies minimal changes to avoid sanitizing or overwriting data that might be valuable in a given project. Since each project or each scan site on a multi-site project might have different looking DICOM data, it's incumbent on each project owner or study coordinator to develop a DICOM anonymization script that works for their incoming data. And if you're administering an institutional XNAT that supports many types of projects with wildly varying anonymization needs, you might want to disable site-wide anonymization altogether and rely on each project to set their own anon scripts. Secondly, know what to anonymize. Each study PI will have to recognize the difference between identifiers that should be removed and identifiers that need to be retained but in an obscured way. The series UID, for instance, is considered identifying data, but there may be instances, such as in a clinical trial, where you need to be able to map that session in your XNAT back to the original patient data. For example, if a previously undiagnosed condition is discovered in the course of your image analysis. The scan date is also considered identifying, but it is important for analysis purposes when comparing to other sessions for that same subject. In both of these cases, you want to think about de-identifying as opposed to anonymizing. In the case of the UID, you can simply hash the original UID to create a new one that wouldn't be identifiable if it was accessed in the PACS. In the case of the scan date, a common approach is to use a date shifting algorithm so that relationships between sessions can be preserved, but precisely identifying scan dates are obscured. You'll also need to weigh whether your study will require defacing the pixel data to remove identifying facial features. Third, start working with real data, but not your real system when you're developing your anonymization scheme. Closely inspect your DICOM data to weed out the PHI that can be buried deeply within it. And this is really only possible when you're dealing with actual DICOM that comes off of your source, your scan sources. It's important that you get representative image sessions directly from the dataset that you plan to support, or from the same source at the very least, and use one or more tools like DICOM Browser or DCM Fourche to inspect the DICOM metadata of that session to see how you will need to construct your anonymization scheme. For example, valuable scan parameters can be stored in DICOM sequences, but these can also contain copies of UIDs or other identifiers. Scanner vendors often put information into vendor private tags that aren't explicitly defined in the DICOM data hierarchy. These vendor private tags can contain just about anything, sometimes valuable scan parameters, sometimes a copy of the patient name. Even though these vendor private tags can contain PHI, you can't simply zero them out altogether. There are many scan types, such as functional MRI, DTI, bold, or PET, that often have valuable parameter data that is only available inside these vendor tags. Armed with this information, you can construct your anonymization scripts accordingly. But we highly recommend using a temporary dev instance of your XNAT while you're working this out. And you should work with your IT group to properly isolate that dev instance so that data isn't exposed before you're ready.